Algebra 2 honors. 10.3, we're going to do day 1 notes, which are examples 1 through 4. And so we're talking about two-way tables today. And two-way tables are also known to be a contingency table. And they are a frequency table that displays data collected from one source that belongs to two different categories. Frequency table just means it's a count. How frequent is it? And down below we see that we have attendance versus class. And each entry is called a joint frequency. So 25 is a joint frequency. It's a joint frequency of freshmen who are attending. Marginal frequencies are the sums of the rows and columns. And we'll see this in this next example. There's a lot of vocabulary with this. So in example 1, there are 16 juniors and 24 seniors on the debate team. And so we can write in, we have a total of, 16 juniors, and we have 24 seniors. And of these, 7 juniors and 19 seniors qualify for a state debate competition. So we have 7 juniors qualifying and 19 seniors. So that's the original data given to us. And so then we can figure out, well, it must be 9 that didn't qualify, so that they add up to 16, and 5 that didn't qualify, so they add up to 24. And then if I add here, 26, 14, and the overall totals, both those two boxes and these two better add up to the same thing, or something has gone wrong. And so the marginal frequencies are the 16 and the 24, the 26, the 14, and the 40. It asks you to find and interpret the marginal frequencies. So for the 16, I'm going to get rid of this. Yeah. For 16, it's that there are 16 juniors on the, auto-corrected on me. Juniors on the debate team. And then for the 24, for the 24, it is that there are 24 seniors on the debate team. See if I can get that moved up to where I want it. And then I can draw the arrow. And for the 40, there are 40 students on the debate team. So when it asks you to find and interpret, you have to include these interpretations. And then you have to also interpret the 26. So we have 26 students qualify for the state debate, not team, but competition. And trying to get it to not be capitalized, but I guess it doesn't really matter. It doesn't want to not do it. Okay, so that's good. And so that goes for, excuse me, I'm still learning how to, I don't want it at all. There we go. Haven't done a lot with text boxes on this. And so then for the 14, it is that 14 students do not qualify for the state debate competition. All right, so that's what you have to do in terms of the descriptions. So watch for that word interpret on your homework, and if it's there, make sure you do that. All right, so now we're going to relative and conditional relative frequencies. And here we're going to make it relative to the overall amount. And so there are 7 out of 40 juniors. So we're going to make it a decimal so we can see the likelihood, and that makes it relative. So you're going to need to know the difference between when they just want frequencies, joint frequencies, and marginal frequencies from up above here, versus now they want relative, joint relative frequency. It's the ratio of the frequency to the total number of values or observations. So this 0.175 is a joint relative frequency, and then we can do it with the 9 out of 40, and that comes out to 0.225. And then we can do 19 out of 40. Oops. And that is 0.475. And we have 5 out of 40. And that is 0.125. So those 4 are the joint relative frequencies. But then we have the marginal relative frequencies, and that's when you add up the joint. So think of these are, kind of like here, these are in the center. So outside of them are the margins. So the marginal relative frequencies, we add the 0.175, the 0.225, and we get 0.400. We add 0.475, 0.125, and we get 0.600. We also add the columns. And the first column is 0.650, and the next one is 0.350. And then the 0.650 and 0.3 adds up to 1, and the 0.4 and 6 add up to 1, and it needs to add up to 1 because it's representing 100%. So joint relative and marginal relative frequencies. All right, and then down below, we're going to be looking at a conditional relative frequency. And conditional is like we've had the probability of B given that A has happened. Under the condition that A has happened, it's like that. They are going to tell you based on row totals or column totals. And so we're going to do row totals. So we are going to be doing, if we go back, we're going to have to look at this right here, conditional relative frequency. We're going to have to use this chart above. It is the ratio of a joint relative frequency, which these in here are joint relative frequencies, to a marginal relative frequency. So we're taking those inside boxes related to an outside box. And in the case below, they want us to use the row totals for the ratio. They could have asked us to use the column totals. So you've got to read the problem to know which one they want. So for the juniors, we're going to do the 0.175 and compare that to the 0.400. And that comes out to be about 0.438. And for those who don't qualify, we have 0.225 over, again, the 0.400. And that comes out to 0.563. And for the senior, we have our 0.475 over the row marginal frequency of 0.600, and that's about 0.792. And then, oops, we have our 0.125 over 0.600, and that's 0.208. So if we describe this 0.208, it's part of a given, and that 20.8% is given the student is a senior. The conditional relative frequency that he, she did not qualify for the state debate competition is 20.8%. So it's under the condition, since we are using row totals, it's the row that it's in is your given. So in that case, that 20.8 is in the row with the senior. We could have done it relative to qualifying and not qualifying, but this one wanted it on the row total. So you've got to read the problem to know which way to go. All right. And then finding conditional probabilities. Oops. I'm going to switch off of my tablet here. All right. So you can use the conditional relative frequencies in order to find conditional probabilities. So we have this example. Story surveys customers of different ages. They ask whether they would like to see the store expanding its toy department. The results given as joint relative frequencies are shown in the two-way table. So that's what's given. What is the probability that a randomly selected customer whose age is between 10 and 20 would not like to see the toy department expanded? Well, this right here is a given. Given their age is between 10 and 20. Well, that right there means we are only interested in this column, and we're going to ignore the other information entirely. We're not going to use it. So given we're using that column, what is the probability they do not like to see the toy department expanded? Well, that was 0.17 out of the total of that column, because that's all we're interested in. We limited it to just those people between age 10 and 20. So that becomes 0.17 over 0.23, which is 17/23, which is about 0.739 or 73.9%. And this is actually the probability of A and B over the probability of A, which is that conditional formula for the probability of event B happening given that A has occurred. And the event A is that their age is 10 to 20. And event B is that they do not like to see the toy department expanded. So that's what we had been using in a previous lesson. Part B was the probability that a randomly selected customer who would like to see the toy department expanded is younger than 10. Well, now, who would like to see it expanded, this is my given. So we are no longer using the 10 to 20 column, we are using the row of yes. And so we're ignoring everything else. And so the intersection of wanting that and being less than 10 is 0.09. all over then that row total. And so you get 0.09 over sorry about that. Oh, did I look at, I think I looked at the wrong one. I looked at, my fault. I bet you're wondering where I was getting that. Let's go back here. That's 0.27. I looked at the wrong spot. So 0.27 over the 0.56, which is 27 over 56, which is 0.482, or 48.2%. There you go, that's better. All right, then determining whether replying yes and being younger than 10 are independent events. We are going to check to see if the probability of B is the same as the probability of B given that A has occurred. If these are equal, they will be independent. Because this is saying, given that event A has occurred, the probability of B hasn't changed if these are actually equal. So kind of think through that again. This is saying if event A happens, the probability of B has not changed if these are equal. So this is a way to show they're independent. So I've set this up where my event B is being younger than 10, and my event A is that they said yes. You could have set it up probability of saying yes equal to probability of yes, and then younger than 10. You're still going to test the same thing, so it's your choice, but we just need to show one of them, not both. All right, so the probability that they are younger than 10 is the sum of 0.27 and 0.09, which is 0.36. That's a probability that they are younger than 10. The probability of B given A, you have to go back to the formula for conditional probability. And then the probability that they are younger than 10 and they say yes is that intersection of 0.27. And the probability that A occurs is going to, again, be that 27 over 56, 0.482, because it's the same thing that we just saw in Part B. And so we have, is the probability of B the same as the probability of B given that A has occurred? Well, is 0.36 the same as 0.482? And they are not the same, so replying yes and being younger than 10 are not independent. That would have to be equal for them to be independent. In your homework 13C, the textbook answer is wrong. The textbook answer in 13C should say they are not independent. So just be aware of that when you get there. Oh, and the next example is for day 2 notes, so we're not going to do that right now.